Hello, everyone, and welcome to the Midwestern Archaeology Podcast. My name is Lee Strange, and today we have a very special episode to end the year. Joining me is Dr. Metin Eren. This episode today is the first in a three-part series that I will be releasing in the next couple of months of a conversation I had with Dr. Eren, and we talked for about 2 hours and 40 minutes. So I thought it would be best to release it in 3 different parts, and then when I finish all 3 parts, I will release it all in one big interview so that you guys can listen to it all at once. But just for my sake, I am splitting it up initially for editing purposes. With that being said, let's get on with the show and enjoy. Dr. Eren doesn't just study prehistory, he recreates it. He's an experimental archaeologist, evolutionary thinker, and lifelong flintnapper who has spent over 2 decades reconstructing some of humanity's earliest technologies to understand how they worked, why they evolved, and how they helped our ancestors survive. He explores how stone tools evolved through a Darwinian process of descent with modification, how each chipped edge and flaked surface tells a story of adaptation, innovation, and resilience. He's the co-director of the Kent State University Experimental Archaeology Laboratory, where he and his team conduct hands-on experiments with ancient technologies, replicating Clovis, Folsom, Solutrean, and even Levallois flaking techniques to test real-world performance and challenge long-held archaeological assumptions. A former National Science Foundation graduate fellow, Dr. Eren's work has been funded by agencies from the Royal Society to the European Research Council. His research doesn't stop with stone. He ventures into ceramics, metals, and even modern forensic science, always asking how technology, ancient or modern, reflects human creativity and survival. So today, we're diving deep into his research on the intersection of evolution, invention, and experimentation. Dr. Eren, thank you so much for being on the show today.
Thanks for having me, and thank you for that generous introduction. And I also work in Ohio.
That's right, which is in the Midwest. So, Dr. Eren, how did you first get involved with archaeology and history?
Yeah, well, it really started with the fact that I did not want to be a medical doctor. Generations in my family went into the medical profession, going back even to when I had ancestors in Turkey still. And I don't like blood. And so it wasn't for me.
Understandable.
And I had 2 teachers in high school, Mr. Joe Popelka and Father Lawrence Ober. And they were a science teacher and a history teacher, respectively. And I loved science and I loved history. And it just sort of occurred to me that archaeology is the best combination of 2 things. And so when I was in high school, I contacted Dr. Brian Redmond, Midwest archaeology legend at the Cleveland Museum of Natural History. And I just asked him if I could join his field school as a high school student.
Wow.
And he never had that happen before. And he let me join. And he might have been a little skeptical of this kind of punk kid, joining his crew, but I had a blast. And that was when I was 16 years old.
Wow, 16.
Yeah. And so even before I got to college, I was directing grad students in the field,
Wow.
which they love.
Yeah.
Having some
very novel, I imagine.
high school kid telling them what to do. But no, it was awesome. And so I've known for a very long time that I wanted to be an archaeologist. And so when I went to college, I was really fortunate to study and joined the lab of Ofer Bar Yosef. And he was just an amazing undergraduate mentor to me. And it just took off from there.
Awesome.
Yeah.
So did you know that you wanted to, because we'll get into what experimental archaeology is specifically, but did you know that you wanted to be on the more functional, practical side of archaeology, or was there more of a journey with that decision?
Yeah. It's interesting. I was flint napping as a teenager. There was an archaeologist at the Cleveland Museum of Natural History named Mark Colliker, and he was a flint napper. He showed me he was the first one to show me flint napping. And like everyone does, like I would try to chip out arrowheads from bottles or little bits of flake that I could get my hands on. But all throughout college, Ofer would buy me flint and material.
Oh, nice.
And it was really great because Ofer sort of saw a gap. And really what it was that Ofer saw that there was a generation of flint nappers that was sort of dying out, and sort of experimental flint napping was going to disappear and almost go extinct.
Wow.
And so he really encouraged me to flint nap and helped me learn and all this sort of stuff, and really just to keep it going. And I did, and I worked
Wow.
hard at it. And basically, when I went to graduate school after undergrad, I went to Southern Methodist University with Dave Meltzer, and he was my master's and PhD advisor. And he also encouraged my flint knapping, but he also helped me think like scientifically and how to apply the results from experiments to the past, right? The proper way. And I continued to flint knap, and I got to sort of a plateau, and I just wasn't improving anymore. And you mentioned the National Science Foundation Graduate Fellowship.
Yeah.
It was such an awesome opportunity to win that, because I used part of that money to go over to England. And I essentially apprenticed Bruce Bradley, famous archaeologist and flint napper for a couple years. And Bruce taught me tons. And I kind of got over that plateau and that hump. And then when I got back to the States after that experience at the University of Exeter in England, I started to work very closely with a flint napper named Bob Patton, who, in my opinion, there's lots and lots of great and skilled flint nappers out there. But in my opinion, Bob is probably the best flint napper our species has ever seen. Right? He understood
High
the
praise.
mechanic. Yeah, it is. And I mean, he understood the mechanics of flint napping better than anyone I've ever met, then or since, right?
Yeah.
He also really understood how you can apply experimental results to the archaeological record in a really robust way. So, and then I also had a chance to work with Jacques Pellegrin in France for a very intense 2-week period. So I've had some very influential people, both who were flint nappers and not flint nappers, that really shaped the way I do experiments and apply those results. Yeah. So,
that's awesome.
Yeah.
Yeah, that's really cool. And I think, so it sounds like flint napping was kind of the gateway drug to get into experimental archaeology. Is that fair to say?
I would say that. And it's funny though, because I've gotten to the point now where like I don't think I would continue flint napping if I wasn't doing archaeology. I'm not really interested in flint napping for the sake of flint napping. I'm interested in flint napping so I can learn about the past. And more, I'm doing flint napping, and I'm learning that there's quite a lot I can't learn about the past. But I think a lot of folks who flint nap do it for the passion of the craft. That's just not me. Right?
Yeah.
My passion is learning about ancient people. So I probably wouldn't be flint napping anymore.
Well, you can go to like a Ren fair and see some flint nappers that will make you like a heart or something out of flint and something like that.
The other thing to keep in mind is, and John Shea, Paleolithic archaeologist at Stony Brook, has written this, that we have to be really careful as experimental archaeologists that we're not acting as our own informant, right? And so in that sense, there's very few studies now that I do where I'm napping, and I'm the subject. Sometimes I'll make specimens that we then test for shooting or something like that, but I'm not influencing those results.
Yeah.
Right. If I want to do a study on flint napping or something like the study really needs to be done blind, and I will recruit other flint nappers who don't know sort of the subject or the question I'm asking, because you need to do a lot of these tests blind just so there's no bias. And in that case, I don't need to flint nap anything, which is good, because these 43-year-old hands
are not what they used to be.
No, they really take it, especially with pressure flaking.
Oh, I see.
Yeah.
We have someone that works in our experimental lab, Sam Linton, and she is definitely the best one at our organization. And she's made some pretty good stuff.
Well, I'll tell you, like, honestly, YouTube, probably the best source.
Yeah.
When I was learning, that wasn't a thing. But now there are so many excellent and very technical, highly skilled flint nappers that put their stuff up on YouTube, and you can learn all sorts of techniques and styles. And so really the best resource for flint napping is YouTube.
Yeah.
And then the other thing is just it's practice, right?
Yeah.
You just got to make a lot of gravel.
Yep.
It's like a musical instrument, which you can only be fluent if you do it every day. And there was a period, especially when I was in England for that 2 years, where I was flint napping like 7 or 8 hours a day.
Oh my gosh.
Every day.
Wow.
And then on the weekends, I would go to the Jurassic Coast on the southern coast of England and walk a mile on a shingle beach, go to this outcrop of silicified sandstone, pack 100 pounds on my back, walk back the mile on the shingle beach. And let me tell you,
oh my God,
I was in good shape. Like when you walk on a beach with 100 pounds of rock.
Oh, I'm sure.
But no, that's what I did. And then when I got back to the States, I practiced tons, and you just got to put in the time.
Did that experience just, I'm curious, did that teach you something about maybe thinking about how our ancient ancestors may have transported that? Because that is something that we've been thinking about as well, as kind of like how proximity to church sources and how they may have
They were making
transported them.
the outcrops.
Right.
Now, not all the time, obviously. And throughout this podcast, if I make a statement like that, it's a generality.
Sure.
There's always going to be exceptions. But in my opinion and experience, folks weren't carrying like big nodules of rock around. They were making stuff as much as they could at the outcrop and carrying that.
Which makes sense. It's not a very efficient use of time if you can just bust it out right there.
So. And we've done studies that have shown that as well, that like, so for example, Clovis people in the Midwest, they don't seem to have carried around like these big bifacial cores. When we actually look at the archaeological record, they seem to have made a bunch of small stone flakes first and carried those, which is a prediction that Steve Kuhn actually made in his famous 1994 American Antiquity paper, that it's a lot more efficient for mobility to make a bunch of small things and carry those around rather than the big biface core, right? And that's what Clovis folks did. So, rocks are heavy.
Yeah, absolutely. And before we get too much into the experimental archaeology weeds, just want to ask you, because in the larger field of archaeology, experimental archaeology is something pretty unique. So could you just kind of briefly explain what it is and why it's kind of important? We've been kind of talking about it on the periphery, but what is it as a field?
Yeah. First, let me just say that there's like lots of definitions of experimental archaeology, and lots of people approach it in different ways.
Yeah.
Right. For me, experimental archaeology is the recreation and essentially reverse engineering of ancient technologies. Right. I think that the things that we create in the modern day can be really useful for helping us think about the past. But I think a lot of people who do experimental archaeology make the mistake of thinking that what they've made is the past.
Yeah.
Right? Like experimental archaeology at best is a model, right? It really is it's a tool to help us interpret the archaeological record.
Yeah.
It should never be mistaken for the archaeological record itself, right?
It's a supplement. Yeah,
it's a supplement, right? And to learn about the past, you can't just do experimental archaeology, right? You have to be studying artifacts and the archaeological record.
Yeah.
If you're making things or shooting atlatl darts and you're not actively also publishing studies on artifacts and the archaeological record, in my opinion, you're wasting your time, right? Now, that's not to say people who are skilled flint knappers and they do it as a hobby. No, that's great. You do that. But in terms of using experimental archaeology for scientific purposes, you have to be doing actual archaeological research, which means working with real ancient artifacts.
And that kind of is a question that I was curious about, just kind of as we were walking through the lab here at Kent State and looking at all of these research projects that are amazing. And I'm curious how the data that is collected at real sites, archaeologic sites, kind of informs the research questions that you form here. Because given what you just said, that it needs to supplement our understanding of the archaeologic record. It can't stand independently of those things.
Yes. No, you have to constantly go back and forth if you're doing experimental archaeology, between experiments and the archaeological record, back to experiments and the archaeological record, right? They inform each other, and it forms this synergy where you'll find something in the archaeological record, you want to understand something about it, so you'll recreate it in the lab, right? You'll do some tests on some sort of feature, right? Then you'll go back to the archaeological record and see whether things match or not, and then that may refine how you make samples the next time. It's just this never-ending process. Right? Well, and that's just science in general.
Yeah,
right? I mean,
absolutely.
We're always getting closer to whatever that truth is. We're constantly refining, but we're never quite going to get to a true objective reality.
Right. So, and just kind of building off of that, we talked about the archaeologic record. If listeners look up Kent State Experimental Archaeologic Lab, they will find an absolutely huge expanse of publications that they have published. And they're not just about America or Eastern America. It's worldwide. So from, Africa to North America, and even chronologically in time, it's not from one period that you guys are focusing on. So how do you stay grounded when you're working with such vast different subjects,
Yeah.
vast different scales?
Well, I think it's important to realize that it's all the same subject, right? And especially if you study archaeology via evolution is what
Darwinian, yeah.
Darwinian evolution. And you realize, and this is a synthesis that really hasn't sort of been heralded the way it should have been. But I mean, we now know that culture and technology evolves via Darwinian evolution. No question. And this has been work published by Alex Masudi and Kevin Leyland and Mike O'Brien and Briggs Buchanan and a bunch of other folks, Stephen Lysett. Like, we know without a shadow of a doubt that culture and technology evolve via Darwinian evolution. And once you kind of can understand that, just in the same way that evolution synthesized the biological sciences, right? Culture evolution will synthesize the social science. And so whether I'm looking at the Middle Paleolithic in Oman or the copper culture in Midwest United States, or, excavations of the John Brown house, during historic period, whatever, right? It's all the same subject because all of this stuff is evolving.
Yeah.
In the same way that, we've got the earliest life and then dinosaurs and then mammals.
Whether you're 8 or 80, there's something for everyone at the Archaeological Research Institute. Join a kids' dig, take an immersive tour, learn ancient skills in our experimental lab, or try our virtual reality experiences. ARI makes archaeology accessible, hands-on, and fun for all ages. Come play in the dirt, or just watch others do it. Find programs at exploreari.org. Cool. And by Darwinian evolution, you mean just culture is kind of the result of survival of the fittest, or just the most efficient way of kind of extracting resources and subsistence and all of these things?
Okay, so that's a good question, right? So there are 3 ingredients to a evolutionary system of descent with modification, right? And this is how Darwin understood evolution, right? Those 3 ingredients are variation, some sort of sorting mechanism, and a mechanism of inheritance, right? Both biological systems and cultural systems have both of those 3 ingredients.
Characteristics,
right? Now, a lot of folks, when they hear me say culture evolves, they're like, well, you can't say that. Stone tools don't breed. Well, I'm not saying that. Culture evolution, as we understand it today, and biological evolution, as we understand today, essentially have the last or the same last common ancestor in origin of species. Obviously, there's different mechanisms between biological evolution and cultural evolution, right? You have genes in biological evolution, and animals breed, and you have reproduction, all that sort of stuff, right? So we're not saying that stone tools breed, but we're saying that cultural data sets have variation, which is the raw material for evolution. You have inheritance in cultural data sets, right? Through teaching, learning, copying, imitation, emulation. And then you've got sorting mechanisms like selection, where a particular type of artifact will be chosen because it works better. Or a type of artifact becomes fixed in a population because the person who makes it is very prestigious, right? So there's selective mechanism, and you can also get cultural drift, but the point is that we now know culture evolves, and really anyone who says that culture doesn't evolve, you might as well go ahead and deny biological evolution as well. The evidence is that strong. So the reason why we can really put on all these different geographic and temporal hats is because evolution is the string that ties it all together.
That's awesome. And we're dealing with the same species, whether that's South Africa, Oman, or North America. Well, that is true. That is true.
Yeah, exactly. A lot of work on Lavawa technology in Europe, and obviously that'd be more Neanderthal. We published our new hypothesis on the origin of stone tools this past spring, and that would have been some sort of Australopithecus.
And let's get into that because it's a very fascinating paper. So you described something called naturaliths, and we were just looking at them. So can we explore the findings of that paper? Because we're talking way back in time.
We're talking
a long time ago,
earlier than 3.3 million, right?
Yeah,
because the earliest potential evidence for hominin stone tool napping, right, is either Lomekwi, which is a site in East Africa, or Dakika. Both of those things are kind of controversial. The point is probably around 3 million years ago is when we're getting the first hominin stone napping. Now, what myself and Stephen Lycett and Michelle Beber and Briggs Buchanan and Alistair Key and a bunch of other authors proposed was that you just didn't have hominins one day have this eureka moment, bang two rocks together, make a stone flake, and then say, what can I cut with this?
Yeah.
Right? The behavior of cutting and the selective pressure to cut had to be there first before they start to flint knap. And so what we proposed in this new paper that was published in Archaeology was that hominins maybe were using these things that we call naturaliths, which are rocks flint napped, quote unquote, by Mother Nature, naturally sharp rocks that they could pick up and use for scavenging carcasses and stuff, right? Now, the reason why this hypothesis really hasn't been proposed before was there is this idea that Mother Nature doesn't produce stone flakes in large quantities. In the published literature,
interesting,
archaeologists will say that like naturally sharp flakes are really rare, seldom made, and these are direct quotes. But what myself and I think there's over 20 authors on this paper through field work and giant literature review, we showed that Mother Nature is not only endlessly producing sharp stone flakes, but sometimes is producing sharp stone flakes in quantities that are hard for us to comprehend.
Wow.
Like in the tens or hundreds of thousands.
Wow.
Right?
Yeah.
And so if you're a hominin and you come across one of these sites or, locations where all these flakes are being made, you don't have to nap anything.
Yeah.
You just pick them up and you're good to go. And so what we argue is that essentially maybe for hundreds of thousands, if not millions of years before the first stone napping, hominins were using these naturally sharp stone flakes to do all sorts of cutting. And then one day, right, maybe they're far away from a naturalith outcrop. That's when the eureka moment comes. They're like, oh, well, I need to cut. No naturalists are around. That's where you can then get the pressure. Well, how do I do this? And then they start to flint nap. So the key is just that cutting came first.
That's really interesting. And, I'm wading into waters I'm not 100% familiar with, but this kind of transition from naturalist to human modified stone tools, is this the first example of tool use that we see in hominin, the archaeological record? I guess those would be the most preserved tools.
Yeah, those would be the ones, naturalists, if they exist.
Yeah.
And mind you, just to be clear, we haven't found any naturalists.
Okay.
This paper was a prediction. So, now that the prediction is out there, people may go search sediments in East Africa or Central Africa between 3 and 6 million to look for naturalith. We could be wrong, right? Maybe they don't exist. If they do, I'll just retire because I'll never have a better prediction than that. Like that'd be sweet. But in terms of the earliest technology, no. I mean, in my opinion, because we know chimps and all sorts of other.
Yeah, I wanted to mention that
they use organic materials.
Yeah. So do birds.
Oh yeah, all sorts of animals. Like tool use and culture is crazy common in the animal. And the fact that there's chimps that will make rudimentary spears to spear bush babies in Senegal. Well, if they do that, obviously we know we get spear technology in the hominin lineage. When you've got two sort of sister taxa making the same thing or doing the same thing, you can kind of assume that maybe the last common ancestor also did that same thing. So if I had to make a prediction, I would say that the last common ancestor of chimps and humans also made spears.
Wow.
Now, those spears wouldn't be to go take down a buffalo, but you might make simple spears to kill lizards or birds or something like that, right? So, I would not be surprised, and we actually published this year as well, that, it's reasonable to suspect that spear technology goes back 6-7 million years.
Oh my goodness. And this is based off of your findings here in the lab with the literature review, as you said,
Well,
as well.
this is a different paper.
Yeah.
We did a paper that we published in paleoanthropology where we looked at spear thrusting technology and how deep you can penetrate and all that sort of stuff.
Yeah.
So yeah, it's just lots of different projects.
So when you're looking at deep in the past, you're thinking pre-Homo sapiens, different anatomy, a little bit at least anatomically. Is there any crossover with evolutionary biologists or any kind of collaboration with?
Oh, all the time.
Really?
Yeah, and this is one thing we really try to do a lot of in this lab is we really need to collaborate a lot with engineers, biological anthropologists, artists, right, woodworkers.
Yeah.
I mean, that's just how a lab like this functions. When you've got so many different projects and so many different materials that is potentially relevant to so many aspects of the past, like you've got to collaborate.
Absolutely.
Right? And it's really important to do so. That's why a lot of our papers have so many authors. We're trying to get as much information as we can from a lot of different people. And we find that approach at least makes for the most robust science that we can do at this point, with the acknowledgement that everything we're doing is wrong, right? And that's just the way science is. 100 years from now, people are going to look at our stuff and maybe laugh at it or whatever. But like the goal is not to come up with a finding that's correct, right? The goal is to advance the football of science a few yards down the field so that someone else can pick up that ball and go farther when we're gone. And so yeah, we're not trying to prove anything. We're just trying to contribute.
Yeah, that's awesome. And so I'm curious, when you're out, in the field, so you mentioned that you were going out to Oman. So what exactly are you guys going to be looking at when you go to Oman?
So in Oman, we are actually going to be collecting naturaliths from a field spot that produces hundreds of thousands of these things. It happens to be a wadi, sort of like a river basin, and these chert balls roll down the wadi and they accumulate all of these cracks. And then what happens is that because it's the desert, you get these temperature extremes, right? Really hot, then really cold. And that causes these natural cracks to propagate and then flakes come off. And so you have a whole landscape of flakes in this wadi. And so what we're going to do is go and collect these geologic specimens, these naturalists, and bring them back and assess how well they can cut in controlled cutting tests.
Yeah. And so that's very unique fieldwork, I would say, at least with the archaeologists that I've talked to.
No, so I've done lots and lots of excavate sites, but we also collect geologic samples or particular samples for tests we need to do, which is always better because the permitting for exporting just like rock is way easier than trying to export artifacts, right? So sometimes it's great to be an experimental or have an experimental focus. But I've done excavations and survey all over the place, all over Northeast Ohio, where I grew up. But that's the other thing too that's just great for me is that like I grew up right here, Northeast Ohio. Went to St. Ignatius High School in Cleveland.
Mm-hmm.
So I love Northeast Ohio. So the fact that like I was able to come back and be here with sort of my people in my community is just like the best thing in the world.
Amazing opportunity.
Oh yeah, I love it.
And there's also, from what I understand, there's some paleo sites nearby that are, I'm guessing you've worked on some of these.
Okay.
Yeah.
When I was a teenager and then also as an undergraduate, I worked on the Paleo Crossing stone tool collection.
Yeah, I'm familiar.
Yeah, and Paleo Crossing is a Clovis site in Medina County, Ohio. And I loved working on that collection because it's the largest amount of rock coming from the farthest distance in North America. So 80% of the stone tools come from about 510 kilometers, crow flies, from southern Indiana and western Kentucky. It's Wyandotte Church. And so it's an amazing stone tool collection, lots of fluted points and scrapers and all that sort of stuff. Now, what really made Paleo Crossing intriguing is the fact that when it was first excavated in the early 90s, the archaeologists found what they thought were post molds. And when they dated those post molds, the post molds came back like, very early Clovis dates, right? A couple of the dates were even like pre-Clovis, like 12,000 uncalibrated. But most folks are like, okay, this is a Clovis house. And in fact, there was a small article in National Geographic talking about the earliest house in North America and all this sort of stuff based on these post molds. And like, I'm a real skeptical guy. And my whole life as a teenager and then in college and graduate school, I was always skeptical of this being a house. And what does that even mean? Like, how, like a structure? Well, anyway, little did I know throughout all that study on the Paleo Crossing site that I would have the opportunity to come back to Kent State, Northeast Ohio, and be a professor here. And so when I got the job at Kent State, like one of the first things I did was I contacted Brian Redman. I said, let's re-excavate. And so with Brian Redman and Dave Meltzer and Brian Andrews at Rogers State University, we got funding from Dave Meltzer's endowment, the archaeological endowment, which has been very generous to my research over the years. And we went back and we re-excavated Paleo Crossing. And what was amazing was that we found the original excavation units of the archaeologists from the 1990s. And we could see the outline of the squares, right? So what we did then was we expanded out from there and we filled in from there. And we start to find more post molds. And the post molds actually formed a line between the original ones in the 90s and the ones we were finding 2016 through 2018. And we're like, oh my God, like maybe we do have a house, right? So we collected all the charcoal and all the date, and we sent the specimens out for dating, the charcoal, and the dates came back like AD 1840.
Oh no.
And so what we realized was that there was a Clovis site 13,000 years ago. We find the fluted points. And then 13,000 years later, a different sort of colonizer of the European variety set up a chicken coop or something on that exact same spot, right?
Wow.
And that was what the post molds were. And so we published that research in the Journal of Field Archaeology. So that was it was like one of those things where I was skeptical, and then you're like in it, and you're like, oh my God, like we've got the earliest house. You start to that kind of make it.
Drink the Kool-Aid.
Yeah. And then the data come back and the evidence, and you're like, oh, okay. Well, reality is setting in.
Was that disappointing, or did that kind of affirm your instinct of like
it wasn't
skepticism?
What was great is, and this is something I've learned. I learned a long time ago is like, as long as you're not tweeting about something or putting on social media, you can have whatever thought you want because you're not going to be embarrassed about it later if you're not spouting off about it.
Right.
So I have all sorts of crazy ideas. The difference is because I don't do social media, I never have to eat my own words later.
That's smart. That's smart.
Yeah. So just, shut your trap and stay quiet.
Keep the crazy thoughts to yourself.
Until you've got the evidence.
History isn't just in the books. It's in the soil, the stones, and the stories of your region. Join ARI's regional archaeological tours and explore hidden sites, historic landscapes, and the places where history happened. Led by real archaeologists filled with real discoveries. See the land like you've never seen it before. Check out our tour dates at exploreari.org.
You've worked on Paleo Crossing. I know there's another site, Meadowcroft Rock Shelter in Pennsylvania.
Not Meadowcroft. So Meadowcroft, I would love to work at Meadowcroft. Meadowcroft is just across the border in Pennsylvania, excavated by James Adebaggio. I worked at a site in Oklahoma called Goodson Rock Shelter.
Okay, gotcha.
And that was a lot of fun. We worked there for 3 years, and that was also a bummer. All of my field experiences are bummers. So myself and again, Brian Andrews, we were at Goodson Rock Shelter, and it's just in the Oklahoma backwoods in northeastern part of the state. And initially it was just Brian and I. We dug a really deep hole in this rock shelter, and below some roof fall, we find the base of a fluted biface. And we're like, oh my God, we have a Clovis rock shelter, and they're incredibly rare. So there's Kincaid Rock Shelter in Texas, but the Clovis point found at Kincaid wasn't actually excavated. It was found in the back dirt pile later.
Oh, out of context.
And it's kind of it's kind of a mystery as to why we don't find Clovis rock shelters, right? Because every Upper Paleolithic culture, really around the world, uses rock shelters. All sorts of hunter-gatherers after Clovis use rock shelters.
Yeah.
But we really don't find Clovis rock shelters. And so in our minds, when we find this fluted biface, we're like, we basically have the first Clovis rock shelter. So we were jumping up and down, just two dudes celebrating in the backwoods of Oklahoma. So we then contact Dave Melter, who is my PhD advisor and Brian's PhD advisor. And he's was very generously funded excavations of Goodson Rock Shelter for 3 years. Now, we were pretty sure we had a Clovis rock shelter because we're getting fluted bifaces, and we found several. We had prismatic blades, which are people consider to be very characteristic of Clovis. We had some overshot flakes, which some folks think are characteristic of Clovis. They're not, but some people think they are, right? But we had all the typical stone tools of Clovis. We didn't find a finished Clovis point, but we had the rest of the assembly. And we were also finding these things about 2 meters underground, underneath some roof fall. And what was neat too was there was a transition from this brown sediment to a red sand. So we're like, oh, that must be the Pleistocene-Holocene transition. So we're pretty sure at this point that we've got a Clovis assemblage in Goodson. So we get charcoal samples from the red sand 2 meters below. We send those dates out, and the results come back about 4,500 BP. And we're like, well, those dates have to be wrong, right? Because, stuff moves around in rock shelters a lot. You have rodents and worms moving. So the charcoal, the radiocarbon's wrong. So we then do OSL, right? So they collect the sediment samples, hammer the cores into the thing, and the OSL dates come back, 4,500 BP. And we're like, well, those might be wrong. Sand grains move throughout the rock shelters. It's a very dynamic environment. This is the Clovis assemblage, right? Well, on the last week of the third field season, we found a notched archaic point that had been dated at other sites to 4,500 BP, made on the exact same raw material as the rest of our Clovis assembly. And at that point, we just couldn't deny the evidence anymore. So essentially what had happened was you had this group in the mid-Holocene reinvent most aspects of Clovis technology.
Wow. That's really
7,000 years after. And that's convergent evolution.
Yeah.
It's super common in the biological world. We now realize that it's super common in stone tools. But it's scary when you think about it, because all of these assemblages that people are claiming to be Clovis, if you don't have a finished Clovis point,
interesting,
or a 13,000-year-old date, in my opinion, you likely don't have a Clovis site.
They're that rare.
They're that rare, and convergence is that common.
Yeah.
But that was another one where we had to kind of swallow. You can't deny evidence.
Yeah.
And it sucked, because PBS, this is one where we kind of did have to eat our words, because when we were very sure that Goodson was a Clovis site, PBS came out and filmed at Goodson.
Okay.
And called it a new Clovis site, and they did an interview, and it was PBS First Peoples or something. And then it was the next year where we got all the dates and the artifact and all that sort of stuff. And so the documentary came out, but we were like, oh boy.
Oh no, I got outdated quite quickly.
So
that's
we published
unfortunate.
2 papers. Well, we've published 3 papers on Goodson now. And Clovis technology is not unique to Clovis.
Well, I mean, it's very least a good lesson to keep in mind with researching these things. So a lot of your research does focus on Clovis, the Clovis people, and Clovis technology. So you mentioned that other contemporaneous human groups like rock shelters, but Clovis seems to be conspicuous in their lack of use. I'm sure you have some guesses as to why that may be.
It could be for a variety of, because you also have to remember that Clovis is fairly short. It's probably around 500 to 700 years. Now, there are some folks that think it's even shorter. I have a lot of problems with those studies that suggest that Clovis is 300 years. That seems too short to me. I think Clovis could be 500 to 700 years, maybe as long as 1,000 years. But that's still a relatively short amount of time relative to other periods and cultures, right? It's kind of a archaeological blip. So maybe, right, you have Clovis folks maybe emerging in the southwestern part of the continent. and they went into a cave or a rock shelter, and they ran into a short-faced bear, right? And they were like, oh, hell no. And so, like, from then on, for the next several hundred years, they were just like, no, we're not going in there. Like, Grandpa Bob or Grandma, Martha or whatever, whoever the person was, Clovis, saw this giant thing that could tear your face off. And so maybe it was a taboo. Now, that's something I can't prove. I don't know how you would prove that. But the point is, there could be any number of reasons that are just going to remain archaeologically invisible to us. But it's a weird thing.
It is very interesting. And so just to kind of zoom in on Clovis materials, the eponymous Clovis point itself, you've done a lot of work on as well. And I'm curious, over the years, what has your research kind of revealed about when people imagine and people Google a Clovis point, what exactly was that point used for? Because from what I understand, they were not as effective at piercing and as maybe taking down these huge proboscideans that we kind of imagine that they do.
So there was this impression out there that the Clovis point was some sort of silver bullet for taking down mammoths and mastodons and like basically elephant-like creatures in late Pleistocene North America. And so we did a study several years ago that showed, no, this is just not the case, right? You can put Clovis points on different types of shafts or whatever, and like they don't just magically make the weapon into Excalibur, right? A lot of people misunderstood, perhaps willfully, what we wrote. We published these results that showed that Clovis points don't just make weapons, bazookas.
Yeah.
And they said that we wrote that Clovis folks never hunted mammoths, or they say that we say Clovis folks only could get mammoths from time to time. We didn't. Clovis folks hunted mammoth, right? I have no doubt that they hunted mammoths. I don't think they mowed them down, right? And so the question is not whether Clovis folks hunted mammoths. The question is, did Clovis folks hunt mammoths to extinction?
That's a very key point. Yeah.
The fact that the Clovis point doesn't make your weapon an AK really makes you then have to question whether they were capable of causing the extinction.
Which I know is a huge debate, climate change versus human intervention or something like that.
And so, in this day and age, people will react to things just to signal or to advance their own petty position or whatever.
Most definitely.
So this is why, again, I don't do social media. I haven't for a very, very long time because it's just not worth paying attention to, right?
Yeah.
A lot of the questions that we are asking and answering now, let me rephrase that. A lot of the questions that we're asking now won't have answers in our lifetime. And so the idea that we're going to find answers in the next 10, 20, 30 years, or even while we're alive, I think all of us need to just sort of vacate that idea from our brain.
Yeah.
A lot of these debates in archaeology are going to take several lifetimes to figure out.
Generations. Yeah.
And so this is why we just need to do our best to make the best contribution we can rather than just kind of signal and social media. Right?
Absolutely. Well, and I also think it's important to keep in mind, it's not the Clovis point itself that would even be doing the damage. It's not like by itself kind of floating towards it's being held by humans that are operating kind of as a team, as a group of people, and that maybe cohesion is more lethal and that problem solving is more lethal than the point itself.
Well, that's exactly right. And it's funny because there's a lot of folks who use the atlatl, right? And they seem to be really like upset at the fact that we somehow impugned the reputation of the atlatl. And like, let me tell you, the atlatl is awesome.
Yeah, I love it. Big fan.
Yeah.
Big fan.
We weren't testing the atlatl. The atlatl can do amazing damage. We were testing the Clovis point. And the point we were making was, if you put that Clovis point on a lightweight dart, it doesn't suddenly make the dart this nuclear bomb where you can just take out anything, right? The Clovis point, you could put a small flake on a dart and it would also work.
It'd be lethal.
So we were testing the atlatl. We were testing the thrusting spear. We were testing whether or not the Clovis point is some sort of magical silver bullet.
Yeah.
It's not.
Yeah.
Right? I mean, what we've learned is that there is just tremendous morphological diversity when it comes to the Clovis point. You get giant Clovis points, sort of like the Shaquille O'Neal of Clovis point. You get little tiny ones, the Danny DeVitos of Clovis point. But again, it's just like any biological phenomenon. You're going to have variation that can be selected. And in Clovis, you get tons of variation.
Yeah.
And what we find from microarray analysis and all sorts of other experiments is that these were multifunctional implements. They could be used as weapon tips, but they were also used as knives for butchery and processing things. There's probably other functions to Clovis points that we haven't, figured out.
So it's almost like a Swiss Army knife of the Paleolithic,
which makes
or
sense.
Neolithic.
The Clovis point. That's a good analogy, because if you're a people that is moving through a unfamiliar and largely empty landscape, right? Because, I believe that there was probably pre-Clovis people here.
Yes.
But they were limited, in my opinion, to western and southwestern parts of the continent.
Yeah.
The rest of the continent was empty. So Clovis folks, the earliest dates we have are at like El Fin del Mundo and Aubrey and sites like that. Clovis is developing, I think, in northern Mexico, southwestern United States. But then once it develops, they then colonize the rest of this empty continent.
Interesting, yeah.
Now, if you're colonizing that empty landscape, you're going to want a tool that will allow you to take advantage of any situational contingencies that you need to, because you don't know what's coming around the next bend.
Yeah.
You also want a tool that will last as long as possible and be as resilient as possible, because you don't know if you're going to find a rock outcrop, right, in that new territory.
Yeah, yeah.
And what all of our experiments and analysis of archaeological specimens of Clovis points indicates that, this was a Swiss Army knife that would have lasted a long time if they needed it to. And they made a lot of them. So just it's amazing.
That's fascinating. Yeah. It's fascinating that, the material record kind of reflects this lifestyle and their perspective on this new land that they're coming from, or that they're entering in for the first time. I think that's really important to stress that. That's why they didn't know where local sources of chert. That's why you get at Paleo Crossing,
This is it, right? So if you're a group in southern Indiana at the Wyandotte outcrop, you are going to, because people are smart, you're going to be largely aware of the fact that area to the northeast, well, we haven't really been up there before. We haven't seen too many humans before. We're not just going to go up into that region empty-handed. We are going to gear up. So they did. They picked up, they made lots of tools out of Wyandotte chert, and they carried those tools with them into this new landscape because they didn't know if they were going to find Upper Mercer chert or Flint Ridge chert, right? That wasn't aware of them. They did what we would have done. We were moving into a new place. We would be prepared. And we see that time and time again throughout the entire Paleolithic, that our species and our genus, Homo, has been smart for a very long time and would often make decisions that we would consider today to be rational, economic, advantageous decisions.
Darwinian, maybe.
Well, yeah, exactly.
Yeah, that's absolutely fascinating. And I'm curious, just before we leave, the Clovis point behind, is there any other findings that you've been surprised about with your research in regards to just researching this famous style of point?
Let's see. Well, when it comes to Clovis, I think the big mystery that I'm working on now is if you've got this really successful, useful tool, right? Why does it disappear?
Yeah.
Right. And that's something that I'm working on a lot, and I don't have the answer to yet. I've got some ideas, but and how do later style technologies evolve out of Clovis, and why do they evolve out of Clovis? So maybe in a couple years, come back and I'll have some answers.
Yeah, absolutely. I'd love to. So could you describe that transition out of Clovis to more regional, parochial kind of points as a regression, or is it kind of...
No, I don't think you could call it a regression.
Okay.
And it really depends on the region. I think what we see, for example, with Folsom, is that it becomes a specialization. Folsom points, I don't see any evidence at the moment that Folsom points were multifunctional. Those seem to have been specialized. So whereas the Clovis toolkit, each tool probably could have been used for a variety of different purposes. When we get to Folsom, it looks like the tools are becoming each more specialized, and they're only being used for one thing. And that makes sense if you've been on the landscape for a while. You can know where you're going to go to resupply your rock and your tools and stuff. So you can afford to make specialized tools because you kind of have a sense of where maybe animals are migrating. You can make predictions in a way that you couldn't when you're new to the landscape like Clovis.
Yeah,
So,
that makes sense.
yeah.
Very interesting.